So for binomial distributions, there's a couple properties that we want to talk about just to know how to detect whether something is binomial or not. The first property is that you have to have two outcomes. So you'll have a success and you'll have a failure. The second property is that you have a fixed number of trials. So it will usually say something like out of 10 people, out of 5 tosses of a dice, something like that. And the third thing is that they need to be independent. So probability doesn't change with each trial. So you should be able to read a question and decide whether it is binomial or not. So we're going to do an example together. This one says the probability that a student makes an A on a test in AP Statistics is 28% or 0.28. Out of 8 students, so this is what tells me that it is binomial. What is the probability that? So we're going to define our x. X is going to be your success. So this would be number of students that make an A on the AP Stats test. Then we need to list out our potential outcomes. So you're going to start with 0, and then you will number by ones all the way to your fixed number of trials. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So here's an example. It says exactly 3 students make an A. So anytime you have the word exactly, then you're just going to be highlighting the one that you will be finding the probability for. So you always start with your probability distribution or your probability statement, which is P that X equals 3. And then with that, you will write out what you type in the calculator. This would be a binomial PDF. You'll have your number of trials, so we have 8. Probability of success, and then the last number is going to be your x value, which in this case is 3. And then you will get an answer when you type that into your calculator. To do that in your calculator, it would be second vars and then binom PDF. I don't know what number that is. So once you type that in, you should get 0.2379, and so that would be your final answer. When you're answering this on an AP test, you want to include your probability statement. You want to include what you type in the calculator, and then you also want to include your answer to 4 decimal places. So that's what I mean when I say show your work. You need all 3 of these things. Okay, let's try another one. So it says no more than 5 make an A. So if you want no more than 5, then I would include everything from 0 to 5, but nothing more than that. So to indicate my probability statement, that would be that X is less than or equal to 5. If you're doing a less than or equal, then that will always be binom CDF. Binom CDF is always less than or equal to. You have 8 trials. Probability of success is 0.28. Oh, I want to erase that. And then the last number is always going to be your last number that you want to include, and then everything below. So I want to include 5. and then everything below. If I did not want to include 5, then I would put 4 and then everything below. And once you type that in your calculator, you should get 0.9922. Okay, the next one, at least 3 make an A. So I want to include 3, 4, 5, 6, 7, 8. So I want to include all of those above. When you have something that is a greater than or equal to, so in this case, it would be the probability that x is greater than or equal to 3. The way that you solve that to do a greater than or equal to is you take the whole thing, which is 100%, and then you subtract away the stuff that you don't want to use. So in this case, I don't want to use 2 and below, so I want to subtract that away, and then that leaves me with 3, 4, 5, 6, 7, 8. So I'm going to take whatever a binomial of 2 and below is and subtract that away. So 100% minus binom CDF of 8.28 and then 2. The reason why I put 2 here is because I don't want to include 2, so I'm going to take 2 and then everything below. So this statement right here includes these 3 numbers. I want to subtract that away. And so when I do 1 minus that, minus CDF, because CDF is only less than or equal to, that leaves me with the upper selection that I have highlighted. So once you plug that into your calculator, you should end up getting 0.3973. All right, so for this one it says no more than 5, but at least 2. So I want to include 2, 3, 4, and 5. So my probability statement for that would be probability of 2 is less than or equal to x is less than or equal to 5. So you could do a couple things. You could add the PDF of, like binomial PDF of 2, 3, 4, and 5. So you could have 4 separate PDFs. Or you could take, and this might be a little bit easier, just depends on your way of thinking, you could take binomial CDF of 5 and below. So 8.285. So that's going to give me 5432110. And then I could subtract away this 1, 0, and 1. So I want to subtract 1 and 0. So minus binom CDF (8.28, 1). The reason why I put 1 here is because I don't want to include 1. I want to subtract 1 and everything below it. So then that leaves me with 2, 3, 4, and 5. So once you plug that in your calculator, you should get 0.6953. So you can try that. The next one is expected number of A's, so that's just finding your mean. The formula for that is N times P, where N is your number of trials and P is your probability. So in this case, my number of trials is 8, so mu equals 8 times 0.28. So that would give me an expected number of 2.24 people that would make an A on the test out of 8. Standard deviation, the formula for that is the square root of N P 1 minus P. And you get both of these formulas on the formula chart. So you don't have to worry about memorizing them. So when I plug that in my calculator, you end up getting the square root of 8.28.72, and you should get 1.3218. So these would be your answers. Then it says within one standard deviation. So I'm going to take my 2.24 and I'm going to subtract the 1.32. And I'm going to take 2.24, going to add 1.32. So when you do that, you end up getting a lower bound of 0.9182 and an upper bound of 3.56. So basically I want to figure out what's the probability between these two numbers. If you list out all of your options again, you have 0, 1, 2, 3, 4, all the way to 8. My 0.9182 would fall right about here. And my 3.56 would fall right about here. With discrete, you only use whole numbers. So you only use whole numbers for discrete. We haven't talked about continuous yet. So what you do is you round in towards the nearest whole number. So you always round inward. So I'm going to use from 1 to 3. This is the section of my probability. So you always round in towards your nearest whole number. So 0.91 rounds up, 3.56 rounds down. So I want to find the probability from 1 to 3, which would be binomial CDF of 8.28. I would use my upper bound, which would be 3, and everything below. And then I want to subtract away just 0 and below. So then that would leave me with 1, 2, and 3. So this could be a CDF or it could be a PDF, since it is only one number. And so once you do that, you end up getting 0.7684. So the key thing is just highlighting the numbers that you need and then thinking about what do the numbers represent when you're plugging them in for CDF. Okay, the last one is at least 5, don't make an A. So don't make an A, that's going to change my probability to be 0.72, right? Because they don't make an A. So I need to take that into account whenever I'm plugging it into the calculator. And then at least 5, so I want to include 5, 6, 7, 8. You could do this a couple different ways. I'm going to show you one way, but if you think of a different way, then that will certainly be acceptable as well. So the probability that x is greater than or equal to 5. Greater than or equal to means I do 1 minus, because it's greater than. 1 minus, then I want to subtract away binom CDF 8.72, because I changed it to be don't make an A. And I want to subtract away 4 and everything below. So I put a 4 here. Do not put a 5, because if I put a 5, then it would subtract 5. And I want to keep 5. I want 5 to be in the numbers that I keep. So I put a 4 here. And once you plug that into your calculator, you should get 0.9562. Another thing you could do is you could do binom CDF of 8.28 and 4. And that would be the probability that x is less than or equal to 4. Because if at least 5 don't make an A, then that means that no more than 4 would make an A. So you're just switching the probabilities. Any way that you want to think about it, you would end up getting the same answer. So there's several different ways that you can approach binomial distributions, but with a lot of practice, this should come easier to you. So I hope this video helped. Okay, I'm done now.